Hi everyone, this is Gayatri here and I welcome you all to today's session. So as you all know, today we are going to be discussing the topic permutations and combinations from quantitative ability. So we have got a lot of requests from students saying that they find the questions in permutations and combination very challenging. So in today's session, we'll be looking at the basics of permutations and combinations, right? How do you identify whether a given question is on permutations or on combinations? And also we'll be solving some questions that was previously asked in recruitment drives from this particular topic. So I can see a lot of you online. Hi everybody, nice to see you all here, right? So let's start the session. Okay, so let's start. I'll share my screen with you, and if you have any doubts at any point when I'm explaining the question or any like I'm explaining anything, you have any doubt, please ping me, right? Feel free to ask any doubts that you have. So let me share my screen with you. Okay, before that, see, a lot of students find this particular topic to be very, very challenging, right? They say like if a question on permutations and combinations come on the recruitment drive or in some aptitude test, they immediately feel, oh my God, this is a question on permutation and combination. I'm not going to be able to answer. It's going to be tough. See, it's not like that. The first thing that you should understand is that permutation and combination is a very, very easy topic if you understand the basics of this topic very clearly. If you have a very good understanding of the basics, solving questions from this topic is not at all difficult, right? Okay. So let's move on to the session. So I hope you can share my screen. Right. So first let us look at what is permutation, right? Okay. Can you guys tell me what is permutation? What is permutation? Any one of you, give me your answers. I can see Aishwarya, Rahul, SP, Lakshman Kumar online. Okay, so let me start. See, permutation is nothing but arrangements, right? When you are given a set of items and you are asked to arrange them in a particular order, that is a permutation. Okay, so again. Okay, so permutation is nothing but arrangements, right? And for example, you are given, let's say, two numbers, okay? 1, 2. In how many ways can I arrange these two numbers? 1, 2, 2, 1, right? There are two ways of arranging. So in permutation, the important thing that you have to note is the order in which you keep the items is important. See, for example, take this, there are three items, okay? P, Q, and R. So in the question, they are asking you, you have three items with you. Taking two items at a time, in how many ways can you arrange these items, right? So you have three items, P, Q, and R. Taking two items at a time means, what are the possibilities? You can take PQ, QP, QR, RQ, RP, or PR. See, the important thing to note here is that PQ and QP are two different arrangements, correct? The order in which the items appear is important in case of permutations. So this is the most important thing that you should know about permutations. Permutations is nothing but arrangements, and the order in which you arrange the items is important. And you must all be knowing that the basic formula for permutation is nothing but NPR, right? Which is equal to n factorial divided by n minus r factorial. Now, how do you explain this formula? See, these are very basic things which you know, but I am explaining it so that you have a clear understanding before we move into the problems. So what is NPR? N factorial divided by n minus r factorial. For example, if you have n items and out of this n items, you have to arrange r items. In how many ways can it be done? That is what is being represented by this formula, right? So in this example that we have taken, that is you have three items PQR. Out of these three items, you are taking two items at a time and arranging them means in how many ways can we do it? 1, 2, 3, 4, 5, 6. See, this we have done it manually. So using this formula, you can directly do this, right? 3p2. Out of 3 items, you are taking 2 items at a time, and in how many ways can you arrange it? 3p2 ways, right? That is equal to 3 factorial divided by 3 minus 2 factorial. Now this is equal to, what is 3 factorial? 1 into 2 into 3, that is equal to 6. 6 divided by 3 minus 2 factorial is 1, or that is equal to 6. So this is the basic formula for permutation, right? Now let us look at what is combination. Combination is nothing but selections. So selection means choosing, right? Okay. So combination is nothing but selection or choosing. Out of n items, you have to choose or select some items. In how many ways can that be done? What you should know here that when you are selecting or choosing, the order in which you select is not important. So that is the most important thing that you should know when it comes to combinations, right? For example, see, you have 3 people. Let's say you have 3 people, P, Q, and R. Okay, now I want to invite 2 people for the party. Only 2 persons I can invite. In how many ways can I do? See, either I can invite PQ, or I can invite QR, or I can invite RP. See, I can also invite QP, but these 2 cases are the same, right? Here, note that the order is not important. So that is called as combination. Now, what is the formula for combination? NCR is equal to n factorial divided by r factorial into n minus r factorial. This is the basic formula for combination. Now, here in this question, how do you apply this formula? See, the question is, there are 3 people. Out of these 3 people, you have to choose 2 people. In how many ways can you do it? 3C2 ways, correct? Out of 3, you are choosing 2. So this is nothing but 3 factorial divided by 2 factorial into 3 minus 2 factorial. That is equal to 6 divided by 2, correct? 3 minus 2, 1 factorial is 1. So this is equal to 3 factorial is 1 into 2 into 3. So 6 divided by 2 is equal to 3. So you can choose these people in 3 ways. 2 people at a time, right? You can do it in 3 ways. So this is the basic of permutation and combination that you should know. Once you know this basic, any problem on permutation and combination, you will be able to solve, right? Now we know what is permutation, what is combination, and what are the formulas that you need to do, right? Now let us look at some questions and try to say whether this question is on permutation or on combination. See, what happens is, in a lot of questions, you will have clue words to find out whether the question is on permutation or on combination. Like, for example, if the question is like, I'm choosing some persons, or I'm selecting something, right? I'm selecting some balls, or I'm choosing some balls. Questions like that, you should know that it is from combination. Similarly, if the question is like, I am arranging some numbers, right? Such cases, it is from permutation. So, in most of the questions, you will have a clue word with which you will be able to find whether the question is on permutations or on combinations. But there are also cases where it is not visibly given whether it is on permutation or on combination, and we will have to find it out on our own. So what we see is that a lot of students find this part very challenging, to be able to identify whether the given question is on permutation or on combination. So let's look at how to do that. Now, I've put 4 questions here. So I want each one of you to tell me whether the question is on permutation or on combination. Very easy questions, okay? So let us look at the first question. How many 3-letter words with or without meaning can be formed from the word number? Can anyone say whether this question is on permutation or on combination? Anyone? Hi, come on guys, I saw a lot of people online and nobody is responding. Lakshman, SP, Rahul, Aishwarya. Permutation, okay, good. Priyanka is saying permutation. Excellent, Priyanka. Right? So Priyanka says this question is on permutation. So how do we say that? See, how many 3-letter words can be formed from the word number? So for example, here 3-letter word means, see, NUM is a 3-letter word, correct? Similarly, MUN is another 3-letter word using the same 3 letters. But the thing is, here the order is different, but these 2 are considered as 2 separate cases. So what does that mean? Here order is very important. Satish Kumar says it is combination. No, Satish, it is permutation. Why? See, NUM, MUN. These are 2 different words, correct? Using the same letters. So here what we should know is that the order is important. So So if the order is important and the order has to be taken into consideration, the problem is on permutations. So out of totally how many letters do we have? N, U, M, D, E, R. 6 letters, correct? Out of 6 letters, we have to take 3 letters at a time and arrange them. So in how many ways can that be done? It can be done in 6p3 ways. Correct? So the answer for this question is 6p3 and this question is from permutations. Okay, now let us look at the next question. In how many ways can I choose 2 candidates for a cricket team out of 10 candidates? In how many ways can we do this? So what is this? Okay, what is this question? Is it on permutation or on combination? Okay, Priyanka, Satish, you got it? Excellent. Good. So Priyanka says this is on combination. Correct. This is on combination. Why? See, there are 10 people in a cricket team, right? Let's say A, B, C, D, E, F, G, H, so on. Okay. I'm choosing 2 people out of this 10 people. So if I'm choosing A, B, if I choose A, B also, or if I choose B, A also, both are the same. Here the order is not important. I'm only selecting or choosing. So this question is on combination. So what is the answer for this question? How many ways can I choose? I can choose 2 people from 10 in 10 C2 ways. Correct? Okay, I hope it's clear. Now, let's look at the next question. In how many ways can 8 different models of cars be parked in a row of 10 parking lots? So, how do we do this? Again, permutation or combination? Okay, for the... yes, Sirivella is saying, okay, what is the question? Okay, tell me what is this? This is permutation or combination? Come on, guys. Again, easy question. Shouldn't be taking so long. The third question, is it permutation? Yes. Priyanka says permutation. Yes, correct. It's on permutation. See, you have 8 cars, correct? So, let's say car 1, car 2, car 3, etc. You have 8 cars, C8, 8 cars, which has to be parked in 10 parking lots. So, in how many ways can we park? When we park them in different ways, the order in which you park is very important, right? Each order is considered as one case. So, it is in permutation. So, the number of ways in which you can do is 10p8. Correct? Sai Krishna says combination. How, Sai Krishna? It's not combination, it is permutation. Okay, now let's look at the next question. There are 5 different fruit juices. 3 of the juices are mixed to form a cocktail. Totally, how many types of cocktails can be made with the 5 juices? So, see, there are 5 types of juices. Out of this, 3 juices are mixed to form a cocktail. So, again, is it permutation or combination? Sirivella had some doubt. What was it, Sirivella? You said, can I ask one question? Okay, it is combination. Subbu Reddy says combination, correct. So, how is that combination? See, out of 5 juices, you are choosing 3 juices, correct? The order in which you choose the juices is not important. The order is not important here. Hence, it is combination. You are only selecting. So, any problem that comes, first check whether it is an arrangement problem or a selection problem. Right? Based on that, you can find the answer. So here, the answer is 5C3. Correct? So the total number of juices that you can make is 5C3. Okay, so Sirivella is asking in how many ways can the 26 letters of the alphabet be permuted so that none of the patterns, car, dog, pun or bite occurs. Correct? So, see the question there has to be, okay, Samuel says combination. Yes, Samuel, it is combinations. Now, see, for example, Sirivella, to explain the question that you asked, for example, if the question is like, there are 26 alphabets, correct? Out of this 26 alphabets, if they are telling you like, taking all the 3-letter words, right? For example, we are finding all the 3-letter words that can be formed with this 26 alphabets, and these patterns should not occur, like car, dog, pun should not occur means you just permute and find how many ways can you take 3 alphabets at a time out of this 26 alphabets and subtract the remaining part, which are the ones cases that should not occur. If you subtract that, you will get. Okay, I hope it's clear. It is again arrangement, and then you have to subtract the cases that is not required. So let's move on to the next question. So the next question is from the basic counting principle. Okay. Now, again, coming back to permutations and combination, whenever there is a problem on permutation and combination, there is one very basic principle called as the counting principle that will come very useful while solving questions. Now, first let us look at this question and see how to use the counting principle here. Okay. In a Subway outlet, there are 4 types of breads and 3 types of fillings available. The customer can choose any one bread and any one of the filling to make a sandwich. So how many choices in all does the Subway outlet provide? So this is the question. How do we solve this? Okay, all of us have gone to Subway, right? Very interesting question. So see, for example, let us say that if in the Subway there are 2 types of breads, okay, 2 types of bread 1 and bread 2, and there are 2 types of fillings, okay, F1 and F2. So you can choose any one bread and any one filling. In how many ways can you make sandwiches? See, either you can choose B1 and F1, similarly B1 and F2, or B2 and F1, B2 and F2. So there are 4 ways in which you can choose, correct, the sandwich. Similarly, here they are asking there are 4 types of breads and 3 types of fillings. Now, the basic, see, there is the basic counting principle states that if there is a operation which can be done in m ways, if there is an operation 1 which can be done in m ways, and there is an operation 2 which can be done in n ways, then put together both the operations can be done in a total of m into n ways. So this is what the basic counting principle states. Correct. Karthik got the correct answer. Excellent, Karthik. So if one operation can be done in m ways, another operation in n ways, put together both the operations can be done in m into n ways. For example, if there are 3 operations, so just extend this rule. So operation 1 can be done in m ways, operation 2 can be done in n ways, let's say operation 3 can be done in o ways. So totally in how many ways can we do all the 3 operations put together? M into o. So this is what the counting principle states. So using this principle, we can directly find the answer for this question. See, there are 4 types of breads and how many types of filling? 3 types of filling. So 4 into 3, 12. So there are 12 types of sandwiches that you can totally make. Correct? I hope it's clear. So this basic counting principle will be useful throughout when you solve questions on permutations and combinations. Now, I think we have seen more or less the basics of permutation and combination, how to differentiate between permutation and combination, how to identify whether the given question is on permutation and combination. Now next, let us look at some problems, okay, and see how to solve this. Okay, let us look at this question. Now, this question, I want all of you guys to solve it and give me the answers, right? Then I'll go about solving it. Can anyone give me the answer for this question or tell me how to solve it? Okay, Karthik says 45. Let's see. Let me get some more answers, Karthik, before I start solving it. Okay. TechWines says 40. All right, so let me read the question. there are 2 blue toys, 3 green toys, and 4 red toys. In how many ways one can choose 3 toys such that there is at least 1 green toy in the chosen 3? So, what is given? There are 2 blue toys, 3 green toys, and 4 red toys. Right? Now, see very clearly in the question it is given that you are choosing 3 toys. So, choosing means obviously what is it? It is a problem on combinations. Correct? Now, they have given a condition. When we are choosing three toys, out of these 3 toys, at least one should be a green toy. So, what are the possible cases that will satisfy the given question? See, the first case is there is 1 green toy, right? The other 2 are blue or red. Similarly, there are 2 green toys and 1 is blue or red. Similarly, all 3 are green, correct? So these are the 3 cases which will satisfy the requirement, right? You need at least 1 green toy. When can that happen? When any one is green and the other 2 are blue or red. 2 is green, the other one is blue or red, or all 3 are green. So all these 3 conditions satisfy the given requirement. Now let us see in how many ways can you select toys in such a way that only one is green and the remaining is blue or red. See how many green toys are there? 3 green toys are there. Out of this 3, you have to choose 1 green. In how many ways can you do? 3C1. Correct? Out of 3 green toys, you are choosing 1 green toy. Now, remaining, you have to choose 2 more toys. These 2 toys can be anything. It can either be blue or red or 1 blue and 1 red. Correct? Totally, how many blue and red toys are there? There are 2 blue and 4 red toys. So, totally there are 6 toys. Correct? 6 toys. Blue plus red. Totally there are 6 toys. Out of this 6 toys, you have to select any 2 toys. It can be anything. It can be 2 red, 2 blue, correct? Or 1 red, 1 blue. So in how many ways can I do that? I can do that in 6C2 ways. Out of the 6 remaining toys, I have to select any 2 toys. Now put together, right? See again here, what are we using? We are going to use the concept of counting, correct? What does the counting principle say? See, I can choose 1 green ball in 3C1 ways and I can choose 2 other balls in 6C2 ways. So put together in how many ways can I get this particular pattern? 3C1 into 6C2 ways. Correct? So this is the total number of ways in which I can get such an arrangement. 1 green and remaining is blue or red. Now let us look at the next case. You need 2 green, correct? 2 green means out of the 3 green balls, you have to choose any 2 green balls. That can be done in 3C2 ways. Similarly, the third ball, out of the 6 balls that you have, 6 toys that you have to choose 1 toy, correct? So that is can be done in 6C1 ways. So totally in how many ways can you get this particular pattern? 2 greens and 1 blue or red. That can be done in 3C2 into 6C1, correct? Now the third case is when all 3 are green. So basically you have to choose 3 green from the 3 greens. That can be done in 3C3 ways. So this is how many ways totally? 3C1 is 3, correct? 3C1 is 3. Now, what is 6C2? See, 6C2 is nothing but 6 factorial divided by 2 factorial into 6 minus 4 factorial. That is nothing but again 6 minus 2 factorial, that is 4 factorial. Correct? That is equal to, how do you do this? 3 into 5 into 6 divided by 1 into 2. Correct? Here 4 factorial will get cancelled with 6 factorial. How? 4 factorial is 1 into 2 into 3 into 4. 6 factorial is 1 into 2 into 3 into 4 into 5 into 6. So remaining you will have 5 into 6, or this is equal to 15 into 3, that is equal to 45. Correct? So this can be done in 45 ways. Similarly, what is 3C2 into 6C1? 3C2 into 6C1 is equal to 3C2 is what? 3 factorial divided by 2 factorial into 3 minus 2 factorial, that is nothing but equal to 3. Similarly, what is 6C1? 6C1 is equal to 6 factorial divided by 1 factorial into 6 minus 1 factorial, that is again equal to 6. So this is 3 into 6, that is equal to 18. Correct? Now 3C3. What is 3C3? 3 factorial divided by 3 factorial into 0 factorial. 3 minus 3 factorial is 0 factorial, which is equal to 1, or this is equal to 1. Correct? So what is that final answer? In how many ways can this be done? 45 plus 18 plus 1. That is equal to 64. So the answer for this question is 64. I think Samuel got the answer correctly. Very good, Samuel. The others, I hope it was clear how we did it now. Correct. 64. Everybody got 64? Good. So can you tell me why are we adding here? See, here and all we multiplied, right? Two things are happening. So put together in how many ways will it happen? We multiplied. Why are we adding here? See, because it is an OR condition, right? Either you take one green toy, or you take two green toy, or you take three green toy. Whenever there is an OR condition, you add. Correct? Whenever there is an AND condition, you multiply. Another thing that you can keep in mind while solving questions. Okay, so the answer for this question is 64. I hope it's clear. Now let's look at the next question. Okay. In a cricket tournament, each participating team plays once against every other team, and in all 36 matches are played. Find the number of teams that participated in the tournament. So how do we solve this question? Can you guys try to solve it and give me the answer? See, these questions you should remember, you should know that these are actual questions which have been asked in the placement. And when you actually solve it, you see how easy it is to solve. So permutation and combination is not at all a difficult or a very challenging topic. Just get your basics right, you will be able to solve it. Can anyone give me the answer for this? Karthik says 9. Priyanka says 8. Any more answers? Ramni says 8. Samuel says 9. Okay. So again, before solving a question, first let us look at what is the logic behind the question. Now they are playing cricket match. Okay, in all 36 matches are being played, and each team plays with every other team at least once. So let us assume that totally there are n teams. Okay, n teams are there. Now to play a match, how many teams are required? You need only 2 teams, correct? So out of these n teams, you are selecting 2 teams at a time. Okay. Now, totally in how many ways can you select 2 teams out of n teams? You can do that in NC2 ways, correct? So what is NC2? NC2 is nothing but the number of ways in which you can select 2 teams at a time from n teams. Now, in the question, it is very clearly given that each team plays once against every other team. So, what is NC2? This NC2 is nothing but equal to 36. When you are selecting 2 teams at a time from a total of n teams, the total number of ways in which you can do that is nothing but equal to 36, or that is equal to the number of matches that can be played. Now, what is NC2? It is nothing but n factorial divided by 2 factorial into n minus 2 factorial. It is equal to, what is n factorial divided by n minus 2 factorial? It is nothing but n minus 1 into n. Correct? How am I doing this? I hope this step is clear. See, n factorial is what? N factorial is 1 into 2 into up to n. N minus 2 factorial is 1 into 2 into etc. till n minus 2. Correct? Here, so n factorial is n minus 2 into n minus 1 into n. Correct? So when you divide both, all these terms get cancelled. You are left with n in minus 1 into n. So this is equal to n minus 1 into n divided by 2 factorial, that is equal to n minus 1 into n divided by 2, or this is equal to 36, or I can say n into n minus 1 is equal to 72. So when you are multiplying 2 consecutive numbers, the answer you get is 72. So what should be the numbers? The numbers are nothing but 9 into 8, correct? 9 8s are 72. So what is the value of n? N is equal to 9. Correct? So answer for this question is option B. I hope it's clear. So let's move on to the next question. So the next question is as follows. 8 boys participated in each of 5 different competitions. In how many ways can the winner prize be given for all the competitions? So how do we solve this question? Eight boys participated in each of 5 different competitions. In how many different ways can the winner prize be given for all the competitions? You guys there? I'm unable to see your chat. Yeah, okay. Priyanka says the previous problem was similar to the handshake problem. Yes, Priyanka, very true. See, I'll just explain to you guys what the handshake problem is. Let's just go back to the previous problem. I got your chat a bit late. Okay. So, see, you should know that like similar questions, that another type of question that you can expect from this particular topic is like they'll say that there are around, there are some n number of people in a party and each person is giving one handshake to every other person in the party, and there are totally 28 handshakes that happen. So how many people are there? So when such questions come also, use the similar concept, right? Similar logic. So let's see, for example, if the question was there are totally 28 handshakes and there are n people in the party and each person handshakes once with every other person, again the same concept, nc2 is equal to 28, and you can go about solving the question, right? Okay, so let's go to the next question that we were doing. Yeah. So this is the question. 8 boys participated in each of 5 different competitions. In how many different ways can the winner prize be given for all the competitions? So how do we solve this? Satish Kumar has given me the answer as D. Srivella says D. Samuel says 8P5. Okay, see, as I always say, when you get the question, try to understand what are the different possibilities that can come. Somebody says 5, okay. See, 8 boys participated in 5 different competitions, okay. So what is there? There are 5 competitions. 1, 2, 3, 4, and 5. 5 competitions are there. C1, C2, C3, C4, C5. Okay. Now, how many people are there? There are 8 students who are participating. Now, the first competition, in how many ways can the students win the first competition? It can be won in 8 ways, correct? See, the first competition can be won by any one of the 8 students. Let us say the students are S1, S2, S3, etc., S8. Okay, there are 8 students. The first competition can be won by either S1 or S2 or S3 or S4 or S8. Correct? Totally, any one of the 8 people can win the first competition. So I can say that the first competition can be won in 8 ways. Now let's look at the next competition. Again, for the next competition, how many people are participating? 8 people are participating. Out of this 8, again anyone can win the second competition. So in how many ways can the second competition be won? It can be won in 8 ways. Correct? Similarly, there is a third competition. Again, how many boys are participating? 8 boys are participating. And anyone can win the competition. So in how many ways can the students win the third competition? Again in 8 ways, because any one of the 8 boys can win. See, note here that there is no such constraint that is given saying that one boy can only win one competition. Nothing like that is given. So any one of them can win any of the competitions, right? Similarly, the competition 4 can be won in 8 ways. Competition 5 can be won in 8 ways. Correct? So what is the total number of ways in which the competition can be won? Now, first operation is done in 8 ways, second operation in 8 ways, third operation in 8 ways. The total number of ways. Again, what principle are you using here? You are using the counting principle. So the total number of ways is nothing but 8 into 8 into 8 into this. It is equal to a to the power 5. This is the total number of ways in which the competition can be won. Is it clear? Is it clear, Venkatesh, Samuel, Techwines, Rohit? A to the power 5. Correct. Clear? Okay. So I hope with this you have understood the basics of permutation and combination and what are the, like how to identify whether a problem is on permutation and combination, how to go about solving the question. You have got a basic idea, I hope. So with this, we come to an end of our session, right, for the problems taken for this session. So if you guys have like any doubts, please feel free to ask in this particular topic if you have any doubts, right? Any doubts that you have in permutation and combination. See, the other types of problems that you can expect from permutation and combination is problems where, like, let's say, see, there is a word, okay, called adroit, or some word like explanation, where there are vowels or letters are repeated, and the question will be like, in how many ways can you arrange these letters in the given word so that the vowels appear together or the consonants appear together. So questions like that you can you can expect from this permutations and combination. Then you can also expect questions on like ranking based questions. Like for example, there is a word named axiom. Okay. Now this word is being permuted in all possible ways, and what will be the position of the word IOMXA? Right. Questions of that type. Then again some puzzle kind of questions like how we solved, right, that cricket playing question. The questions which are of the format of puzzles are actually very easy questions. You will have to only know the logic behind it. Okay, so these are some of the type of questions that you can expect in this session, I mean this topic. So any other doubts that you have on this topic, please feel free to ask. So we have taken very limited problems for this session. Right, permutation and combination is not a topic that you can finish in like 1 hour's time. So you have to practice more and more questions to have a very clear understanding. Again, in permutations and combinations, you have a lot of questions that comes from picking up balls, right? Like how we did. That is one type of question that you get. Like there are some balls in baskets. You are picking the balls. In how many ways can you do questions of that sort? Thank you, Samuel. That good to know that the session was very useful for you. Right? So, any doubts? And if you see permutation and combination appears in most of the aptitude exams nowadays, right? Like companies like TCS, they really love to test students on these topics. So, you should have a very good understanding of this topic before you attend the drive. Next session, we'll be updating it in our portal. You can refer to our portal, right? When the next session is. Come on, no doubts. Everything is clear. Huh? Yes, permutation and combination, you can definitely score. As I said, understand the logic. What is the basic thing that is given in the question? First, classify whether the question is an arrangement problem or a selection problem. If you have that basic understanding, you will be able to solve any question. See, you can refer a lot of books. There will be a lot of formulas that is given. You needn't necessarily know all those formulas. Some basic 2 or 3 formulas, if you are aware, you will be able to solve the question and score marks. Okay. Now, Priyanka, the question that you asked is very similar to the question that we solved, right? So, how many lottery tickets do we have? We have 6 lottery tickets. It has to be distributed among 4 people, correct? Okay, let us solve this question that Priyanka asked. Let me share my screen. There are 6 lottery tickets to be distributed among 4 people, correct? P1, P2, P3, P4. 4 people are there. Now, if all 4 people can get any number of tickets, okay. So you guys try to solve this answer first by the time I solve it and give me the answer. Let me see. Priyanka has asked a very good question. Please refer to the chat for a question. She's asking in how many ways can 6 lottery tickets be distributed among 4 different people if all the 4 people can get any number of tickets. No answers, huh? Come on, yeah, we just solved a similar problem. This is just a variation of the type of problem that we solved. Okay, let me solve it for you. See, there are 6 lottery tickets, right? And how many people are there? There are 4 people. Okay, now the first lottery ticket, right? Let's say lottery 1, lottery 2, lottery 3, lottery 4, lottery 5, lottery 6. Now, these 6 lottery tickets have to be distributed among these 4 people, and any person can get any number of lottery tickets, correct? So, in how many ways can I do it? See, the first lottery ticket, in how many ways can I give it? I can give it, the first lottery ticket can either be given to person 1, person 2, person 3, or person 4. So, in how many ways can I distribute the first lottery ticket? I can do it in 4 ways. Similarly, the second lottery ticket can either be given to person 1, person 2, person 3, or person 4. Again, it can be done in 4 ways. Similarly, the third lottery ticket in 4 ways. So, totally, all the lottery tickets put together, in how many ways can you distribute it among the persons? 4 to the power 6. Samuel, it is 4 to the power 6, correct? See, I am not solving the question that is given on the screen. I hope it is clear. I am just clearing Priyanka's doubt. Satish, I was solving the question that is given by Priyanka in the chat. So it is 4 to the power 6. Each lottery ticket can be given to any 4 persons. There are totally 6 lottery tickets. So 4 to the power 6 ways. Samuel, I hope it's clear. Yeah, I hope the question was clear. So, Priyanka, is it clear? Karthik is asking me questions on AMCAT. See, AMCAT questions, any question mostly asked. In AMCAT on this topic, all these type of questions that we solved today, you can expect in an AMCAT exam, right? Samuel got it as 4 to the power 6. Excellent. Great. Okay. So, I hope that is it. Any more doubts? Yeah. Excellent. So, with that, we'll wrap up the session. Right. So if you are a fresher who's trying for an IT career, or if you are looking at improving your coding skills, TalentSprint is the right place to be. Do check out our website to know what are the courses that we offer. Right. All the very best with your preparations, and it was nice interacting with all of you. Right. So I'll see you in the next session. So it is bye from Gayatri. Bye.